Hello everyone, welcome to our project Smart Door. We the batchmates Sneka, Tarun, Saktivel and Tamil Selvan are here to present about our project Smart Door. Myself Tarun, I will be explaining the overview of our project. So the basic components required for an IoT project are mentioned here. So for any IoT project, there will be a main component which is a microcontroller. In our project, we have used a NodeMCU microcontroller. To be more specific, we will be using ESP8266 system on chip. And the second component is magnetic reed switch, which working will be explained in the upcoming slides. The next will be the Telegram bot, which is a social media platform. For example, we are aware of the Instagram, Twitter's, Telegram, right? So it is one such a social media platform in which we'll be creating a bot. Uh, what is bot and how it works will be explained in the upcoming slides. And we need some cables to connect the NodeMCU and the magnetic reed switch. First, the NodeMCU. The NodeMCU is a microcontroller, as already said, it's a microcontroller which is operated at a voltage of 3.3 volts, and it has 16 digital pins and one analog input pin. And you got SPI, all the specifications mentioned here are available in NodeMCU. Apart from these, NodeMCU is have a specific capability, that is inbuilt Wi-Fi functionality, which makes it unique for a IoT project. Since it has an inbuilt Wi-Fi functionality, there are different modes it can operate on. One such mode is station mode, in which it can connect to the other access points or hotspots, and the other mode is a soft access point mode, which is not a completely access point one, but it transfers the data received from one network to the other network by acting as an access point for the other network. And not only these two modes, there are one more mode which is known as dual mode, in which it can operate as both station mode and soft access point mode. This is generally used in mesh networks. The next is a magnetic reed switch. Magnetic reed switch is nothing but it consists of two magnets. One is a permanent magnet and another one is an electromagnet. Whenever the permanent magnet comes near to the electromagnet, the reed switch acts as a closed circuit. And when it is when it is an open space, there is permanent magnet is away from the electromagnet, then the electromagnet acts as a open switch. Next, Telegram bot. As I already said, Telegram is a social media platform that is used by most of us people today. Chatbot is nothing but one which mimics the humans and interacts with the users. Basically, chatbots can be classified as rule-based and AI-based. In rule-based, they respond based on the predefined responses. For example, if I say, "How are you?" it says fine. For example, I ask about what's your name, it says its name. It is being loaded in the database with the predefined values. It just replicates those values in the chat. When it comes to AI-based chatbots, it learns by communicating with the real-world people, and it adapts to the real time. Most of the chatbots that we're observing in the websites are AI-based chatbots, but in our case, since for simplicity, we have used a rule-based chatbot, which just responds to the user based on the available resources. And talking in technical aspects, we have used HTTP protocol, which falls under the layer of application layer. We know there are many layers available in the network. For example, physical layer, data link layer, network layer, transport layer, application layer. The main protocol that we are using in our project is HTTP protocol, which is nothing but hypertext transfer protocol. This protocol follows a request-response communication model. That is, whenever a client requests a server, the server looks for the resources, and if there's any resource available, it shares the response with the required resources. But if there's no resource, it responds with some error status code that conveys to the user that the following resource is not available in the server. Now let's look at the block diagram of our project. Here basically the left side mentions the mobile, and and we will be using a NodeMCU here. The mobile communicates with the NodeMCU through the request response cycle, that is the HTTP to HTTPS protocol, and the D3 pin is configured as an input pull-up. That is, whenever by default the D3 will be at the high state, and the other end of the reed switch is connected to the ground. Now you can observe that since there is no magnet near to the reed switch, it acts like an open circuit. So the D3 remains in the high state irrespective of any inaudible conditions. But when the switch door is closed, assume that the moving part of the door consists of the magnet, and the nearby the fixed part of the door consists of the reed switch. When the moving part of the door is closed, that is near to the permanent electromagnet, then the switch acts as a closed circuit. So the D3, that is high state, will be transferred into low state because it is connected to ground. So the energy disperses to the ground, and the D3, when you read the D3, you can get the value of low state. By distinguishing between high state or low state of the D3 pin, we can say whether the door is closed or open. Now let's look at the program that is uploaded in the ESP8266 NodeMCU. Let me go to the Arduino, that is Arduino IDE. Here you can see that the necessary libraries are being imported. For example, the ESP8266 Wi-Fi, which is used to like it's a module that helps us to configure the Wi-Fi in the inbuilt Wi-Fi in the ESP8266 easily through some predefined functions. And we will be using a Wi-Fi multi so that we can connect to not only a particular SSID and password, that is a particular access point, we can connect to multiple access points whenever they are available. So for example, if I have 3 access points and only one is enabled, so the enabled access point can be connected to the ESP8266 and it can perform the functions needed. And Universal Telegram Chatbot bot is a header file that helps us to configure the chatbot and get the responses and respond accordingly. Here you can see that we have given the password for different SSID and passwords, and here is the API key. Yeah, this is a Google script ID that will be explained later. So we have created a client for our Wi-Fi, and this is a Universal Telegram bot. We have created an object of the particular class that is imported in the header, so that it can be used to get the functions and get the use and functions that are available in the class. And this is a door pin D3 which will be configured as input pull up, as I explained in the block diagram. And by default, the door state is considered to be low. So this function is to check the ID of the user, whether he is allowed to access, is authorized to check the status of the door that is available in a particular room. And this function helps in controlling the operations based on the commands given by the user. Like if they say start, hi, or anything, the chatbot welcomes them with some message and the description about how to proceed with it. And if they ask for the state, then it will say like whether the door is open or closed. And this function of handling incoming messages, whenever a message comes in, it checks the message and whether the chat ID of the user is allowed to access the door status or not. And if they are allowed, then only the control operation function will be called and particular performance will be done. The setup function in which only runs only once when the NodeMCU is reset. In this, we will begin the baud rate serial communication, and then we will configure the door pin as input pull up as explained earlier. And we are adding 3 access points in this setup function. And this code is to connect to the Wi-Fi, and once it get connected, it prints the SSID to which it is connected and the IP address. This loop function runs continuously and keeps on checking whether any messages are coming in, and if any messages comes in, it calls a particular functions to take action. And if in case if this code is repeated here, the Wi-Fi code is repeated here in order to make it dynamic. For example, if the network gets disconnected, if we put the code in the setup function alone, it won't get reconnected, and we have to reset every time the NodeMCU, so that it will be a complex task, right? So to avoid this, we have inserted the code again. If the NodeMCU is not like the Wi-Fi NodeMCU is not connected to the network, then it calls the same code to connect to the Wi-Fi, and only then it proceeds. So in this, it waits for this particular delay for bot is to give a particular delay so that the bot keeps responding to all the users without any further delay. So that's all about the code. Now let's look at the implementation part of the code, in which we have uploaded the code that is explained now to the NodeMCU, and the setup is being fixed in a particular door. Now let's look at the door and how the connections are done. So
This is the power supply for the NodeMCU microcontroller, and here is our NodeMCU microcontroller as shown in the block diagram. So as already discussed, the one end of the reed switch is connected to the D3 pin, and the other end is connected to the ground. So this red color connects to D3 and black color connects to the ground. So this is a reed switch, which is this one is a permanent magnet and this is an electromagnet, and the door is in this closed condition. Now let's go to the telegram. Here you can see that bot. This is a bot named as Nika. Let's click start. It says welcome Tarun. Click any one of the following commands /state to request the current door state. So click state. Since the door is closed, it should say the door is closed. And let's open this door, and then it is away from the permanent magnet. So I am clicking the state now. So it says the door is open.
Now we came to the end of the presentation. So we have learned about the smart door, that is IoT based system for that monitors the door from anywhere at any time when it is connected to the internet. So the further future works that can be done in this project are interfacing a ESP82 plus CAM module that makes the door more intelligent. That is transferring the smart door to a faculty availability checker. Let's say some faculties are available in cabin, and whenever we go to meet them, sometimes they won't be available, right? In such cases, to avoid this clash of presence of faculty and absence of faculty when the students comes to meet them, we can interface a ESP82 plus CAM module in the door, so that when it checks for the faculty present in the cabin, and it responds to the students that whether the faculty is present or not. This can be done with the help of image processing algorithms. The next one is for the code that is uploaded in the chatbot in a NodeMCU for now. It is fixed with certain people's chat ID and a group ID. To overcome this disadvantage and make the chatbot common to many people, we can update the data of people who needed this facility in a Google Sheet along with the chat IDs, and we can create an API with the help of Google Apps Script that is available that is provided by Google. And with this API, we can write a code in the NodeMCU that makes it more intelligent by checking whether the user is authorized to communicate with the chatbot or not. Thank you for your patient listening.